Code and Corners, Code and Corners, Code and Corners.
I bet you're intrigued to find out whether I can build this sensor for under £10. What's in store for this video? Well, I'll be deciding the solution, coding it, physically building it, testing it, putting it on the bike and trying it out, and then going over my lessons learned. Why did I think of this video? Well, I've always wanted to do something with hardware, and actually, after Googling it, digital lean angle sensors, they don't seem to be a thing as an aftermarket solution. And I really want this on my bike. So let's get cracking. After much debate with ChatGPT as my first solution, I found out it was possible. Here it is on the screen. Let's run through it now. Very quickly. Step one, you've got your phone connecting over Wi-Fi to a physical device called an ESP32. The ESP32 will connect to a lean sensor, which will record statistics. Those statistics will be stored on the actual ESP32 itself. Then step 6, the phone will download those statistics for you to view. For those of you wondering, an ESP32 is like a mini computer, but it has extra bits on, depending on the type of ESP32, such as Wi-Fi and Bluetooth and cameras. And an extra fun fact about this solution, because it's powered by USB-C, we can actually power the whole device with our phone. We don't need an external power source. It's a very inexpensive solution with AliExpress. The board, the sensor, and the wires are about £2 each. I rounded up. As you can see on the screen, you've got the jumper wires, the ESP32 C3 Super Mini, what a mouthful, and the MPU 6050 lean angle sensor. I had no idea what I was doing. I've never written any code in C++. On the left is my poor attempt of a proof of concept, and on the right is me actually using my proof of concept from my phone. So I plugged the ESP32 in, loaded the code, connected my phone to the ESP32 over Wi-Fi, and then downloaded some dummy data that you can see on the screen there. I got really excited after that, and everything went downhill. As you can see in the video, some LED lights are blinking. They're not meant to be. It's because there's a loose connection. Lo and behold, I had done my research poorly and bought completely the wrong thing, as I can't solder. And as a result of my heavy hands, you can see that I actually broke the board. So that is a problem. I did a lot of research and had to buy the same things again. I was very eager to get my sensor code working. So after much research, I realized I could buy pre-soldered units, such as the ESP32, the sensor, and a fancy board to be able to connect them all up together. Problem was, because it was off Amazon, they cost me an arm and a leg. What it did enable me to do was find my next problem. It turns out that the date was incorrect on the board. I didn't even clock, pardon the pun, that I'd have to set the time on the board. Before I explain how I fixed that particular problem, on the screen you can see a pretty picture that I didn't generate, but it goes over the whole solution from hardware to software. In the middle of this diagram is roughly how I split out the code for this solution. I'm used to Scala. I'd never written in C++. Starting from the left, you've got the website URLs that control the service. In the green box, you've got the iterating code that grabs the current lean angle from the sensor and stores it somewhere, as in on the ESP32 board in memory. Then you've got the actual interface with the sensor to calculate that lean angle, or the lean angle magic. And then 2 boxes on the right is kind of how it's stored and what the data looks like when I get it back on the phone. To fix the problem that I mentioned earlier, cast your eyes to the yellow box again. How I fixed it, I would load up the start URL on my phone. There would be a start button. I would click it. It would make a request to the ESP32. There'd be some magic under the hood to send my actual phone device time to the ESP32 to set it there and then permanently. I think this was an anti-pattern to what it was meant to be, but I really didn't want to connect the ESP32 to the actual internet to get the date time. So we went with that. And on the screen, it's all come together. I'm pretending I'm a motorbike. I'm wiggling it to the left and right. and I'm also printing out on my laptop the roll and pitch. These are different sensors within the sensor that I bought, left and right and forward and back. So the roll is the left and right, the one that I really care about, and the pitch is how much the bike dips and raises during riding. So if I harshly braked, it would affect the pitch dramatically. I found out that we should really use both of these values to calculate the lean angle, but for a proof of concept, I think just one sensor's value is fine, the left and right value. We've now got to my garage, finally. Trying to work out where to mount this. It's very delicate, very fragile. Finally, I decide to just whack it on the fuel tank, stick it on, hope for the best. And we finally got there. We can test it on the motorbike. I did want to create a raw experience, so this is the first time I'm actually testing this on the motorbike. I've already connected to it over Wi-Fi. I've navigated to it via an IP address. I've hit the start button to start recording my lean stats, so it's recording it right now. I'm putting on my gloves and I'm about to take it out and give it a spin. Just a note, you have no idea how distracting it is having a bunch of wires in your fuel tank whilst riding. And here we're about to pull over. Luckily this isn't a blooper of me dropping my bike. We've finally pulled over after about 7 minutes. We've hit the stop recording URL because we're already connected to the device. We're eagerly trying to download our lean stats and the whole device crashes. No lean stats. It turns out I had too many lean stats stored, as in my ride was too long and there were too many lean stats to download at once to my phone. It ran out of memory. I realised this huge mistake very quickly and I had to change tact because I didn't want to go back home. I'm going to do a very quick ride here where I've clicked start again. The device is already booted up again. I've clicked start, about to start the bike up again. Bit annoyed, but we'll deal with it. I had to leave this in as it's highlighting my poor editing skills. I thought it was funny. What we're really doing here on the ride is just going round and roundabout and pulling up again. A minute's worth of ride. We've got the phone out again. We've stopped recording our lean stats and we're trying to get them onto the phone. Fingers crossed. And there we go. Our real world stats. Can we interpret them now? I don't think so. You've got some negative numbers where I've leaned one way, positive where I've leaned another. I can't really interpret them. Can you? After that bamboozling result, I thought I'll just wiggle it from left to right. Surely I'll get better results than that. So here I am, wiggling, after already starting the scheduler again, starting recording again, that is. And here's the results. Can you interpret them? I tested several more times and I got very similar results. So it begs the question, did it work? Well, when it was in my hand, it did seem quite promising. But when it was on the bike, I've realised now it was affected by a lot of factors, and only using one sensor or one axis isn't enough. This brings me to my many lessons learned. Here are my top 4, but I have a lot more. Hand on heart, if I hadn't have rushed this, I could have built it for under £10. Based on what you saw in the video, it became very apparent that the data recorded was quite unwieldy. I should have recorded much less or recorded an average so I could view it at the end. That was just impossible to interpret. To be honest, egg on my face. I decided on a solution and didn't deviate after I'd decided. I should have mounted my phone to the handlebars and rendered those angles in real time whilst riding, rather than recording and looking after. I had no idea when I was leaning and how that compared to the stats I was looking at on my phone. And a final one, it's bigger than I thought. Mounting that on the tank was a bit sketchy. I'm going to be creating other videos like this. I should have created a reusable mount there and then. Anyway, I think that concludes this video. Did I build a motorcycle lean angle sensor for under £10? Kind of.